All right, we're going to start with what's called the Spearman rank correlation coefficient. Spearman rank correlation coefficient. And our abbreviation for this guy is R sub S, Spearman rank correlation coefficient. This is kind of our non-parametric version of correlation, which we did, a few chapters ago. And again, table L in your book, in this book, it's page 794. That is our table for critical values. Okay, so your critical values come from the table in the book. And this is what your test value looks like. R sub S equals 1 minus, so 1, separate that from, there's a fraction coming on this side, 6 times summation d squared, so summation of the d squares, and we'll talk about that in just a second, divided by n times n squared minus 1. Okay? So, only really need to identify what is n and what is d. So let's identify that. N is the number of pairs, or the number of matched data. So n is the number of data pairs. Because remember, when we're doing correlation, we have matched pairs, x and y, right? And d is our difference ranks. So difference in ranks. So obviously that means we have to rank stuff. Okay, so D is the difference in the ranks, and N is just the number of data pairs. All right, let's jump into an example here. 6 actors were ranked by male and female patrons for their ability and appearance. The data are shown below. At alpha equals 0.05, is there a relationship between the rankings? Okay, so we have ranked data for actors. So we have actors. And there were 6 of them, and then they were ranked by males and females. So these were the rankings. So we'll call this actor A, B, C, D, E, F. These are our 6 actors. And this is how the males ranked them, and this is how the females ranked them. So let's do the males first. 6, 3, 2, 5, 1, 4 were the rankings. And the females ranked these same actors 4, 5, 1, 6, 3, 2. Okay? So we're lucky on this problem that they already gave us the ranks. It could have been just as easily that they gave us scores and you would have had to rank those scores. Does everybody understand that? It's just the same ranking process we've been doing the last week. So we got lucky here in that they've already ranked it for us. So that's kind of nice. But if they had just given you scores like 1 to 10, then you'd have to rank those and then rank these as well. Okay? All right, and the question is, at alpha equals 0.05, is there a relationship between the rankings? So at alpha equals 0.05, is there a relationship? And then it will say, use the Spearman rank correlation coefficient. Okay? Okay, let's get this started. The HO and the H1, it's still going to be back to rho. Rho equals 0 versus rho not equals 0. So rho equals 0 is saying there's no relationship in the rankings. Rho not equals 0 is saying there is. So no relationship. And there is. Okay? And that's very similar to what we've already done before with correlation, a couple chapters ago. Critical value is step number 2, and then you have to go to your table in your book. Okay? In this edition of the book, it's on page 794, it's table L, critical values for the rank correlation coefficient. All right. So notice it has alpha and it has n. And alpha in this problem was given at 0.05. And n in this problem is how many actors, basically, because it's pairs, males and females. So 1, 2, 3, 4, 5, 6. So go down to n equals 6, and go to alpha equals 0.05, and what do you have there? What is the critical value? Yeah, 0.886. And since this is a two-tailed test, equals not equals, it's plus or minus 0.886. That's our critical value. Okay, and I just got that right off the table using the alpha and using n, and that was it. All right, test values next, but I have a little bit of work to do because I have this summation d squared. Okay, so that means to us we have to add up the d squareds. D's are differences in ranks. D squareds would be the squareds of the differences in ranks, okay? So I need to make a couple of columns here. You're going to have to make a D column, and then you're going to have to make a D squared column. So D is the difference in the ranks. So if you look at the first one, the males rank this after 6th, and the females rank this after 4th. These are rankings. So what's the difference in the ranks? What is 6 minus 4? 2. Everybody with me on that? So go through and do the difference in the ranks. 3 minus 5 is negative 2. The next one's 2 minus 1, which is positive 1. 5 minus 6 is negative 1. 1 minus 3 is negative 2. And 4 minus 2 is positive 2. So those are my differences. D squared is just going to be the square of this column. So that'll be nice. 4, 4, 1, 1, 4, 4. If I add up this column, that would be the summation of the d squareds. And that's what I need for that test value. Is everybody with me on that? Here's my d's, differences in the ranks. Here's my d squareds, I squared the differences. And if I add this column up, that'll be the summation of the d squareds. So let's just add this 8, 9, 10, 14, 18. Okay? And that's all I really need. That's the only significant piece that's going to require a little bit of work. Okay, go ahead and do the test value then. So we have 1 minus 6 times 18. Let me just snake the work underneath here. So I have 1 minus 6 times 18. What is n in this problem again? 6. So I have 6 times 36 minus 1, 35. So you have 1 minus, and then the fraction 6 times 18 divided by 6 times 35. So let's do that. This one's kind of nice. The 6 is reduced out, so really it's just 18 divided by 35. And to 4 decimal places, I'm getting 0.4857. Okay? My critical value is plus or negative 0.886. So it would have had to have been 0.886 or higher, or negative 0.886 or lower for us to reject. Okay? Since 0.4857 is not in the rejection region, step 4 is do not reject HO. And if I do not reject HO, I'm saying there is no relationship between the ranks for the male and female patrons on the actors. Okay? This is the Spearman rank correlation coefficient. It's our non-parametric version of correlation. And it relies on you ranking the data and then doing the summation of the difference squareds, the difference in the ranks squared. And that's it. Any questions on this one? Okay, it's relatively easy as long as you understand the steps. Okay, great. Let's move on to our very last type of problem, and it's called the runs test for randomness. So the question is the data random or not? Okay, let's just jump into an example and then we can talk about how it works. A student believes the answers to his history test are not random. Test the claim at alpha equals 0.05. Okay, so a student believes that this test is not random.
This is a run rank thing? Or
Yeah, runs test for randomness. Runs test for randomness. Okay, so here we go. True, 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 false, false. True, true, true. 1, 2, 3, 4, 5, 6 falses in a row. Then 3 trues. Then 3 falses. Then 3 trues. Then false, true, false, false. Then true, true, false. Okay. So, student believes that these answers are not random. Test the claim at alpha equals 0.05. Okay. So our assumption is things are random. And if they're not random, if there's a pattern, you're going to have to state that in the H1, okay? So HO, it's random. H1, it's not. Okay, so our assumption is things are random. Okay, we have to find what is called the runs. So the number of runs is how long it goes, the string goes before it changes, okay? So for instance, true, true, true is the first run, because it hasn't changed, and then it changes to false, right? And then false, false would be the next run. So go through and circle how many runs you have. And then it goes true, true, true. And then a big string of falses, so that's all one run. Then we have 3 trues in a row. And we have 3 falses. And then 3 trues again. And then a false, so that is just a single false is a run. And then a single true, that's another run. And then we have 2 falses. Then 2 trues. And then a false. Okay? So as long as it doesn't change, that's all one run. Alright, so let's count how many runs we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does everybody agree that we have 12? Yeah. Okay, so the runs, there were 12. Okay, then the next thing is we have N1 and N2. And N1 and N2 are the numbers of trues and falses. In this case, it's trues and falses. And N1 is the larger, okay? So count how many trues we have, count how many falses. Whichever one's more, you're going to put as N1. If there's a tie, then it doesn't matter. Okay, so let's count how many trues we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 trues. And let's count how many falses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, 15 falses too. Okay, cool. Okay, so on this one, you could put either one because it doesn't matter, they're both 15. But let's say there were 16 trues and 14 falses, then clearly 16 would be N1, right? So N1's larger, just keep that in mind. But in this case, 15 and 15. Okay, great. We need to take that information to our critical values for the number of runs. So go to, in this book, in this text, it's page 795. All right. Now, across the top, you have value of N2. Across the column on the left, you have value of N1. In this case, they're both 15. So go to where 15 and 15 both match up, and you have 10 and 22. Does everybody see that? So when you match up the 15s, you have a row with a 10 on top and a 22 on bottom. And that is your critical values for this test, 10, 22. Okay? 10, 22. And here's your statement to decide whether you reject or not. So write this down in your notes. Star this guy. Reject HO if the number of runs is less than or equal to this number or greater than or equal to this number. Okay? So reject HO if the number of runs is less than or equal to the first number, and I'm just going to put 10 because it's 10 in this problem, or greater than or equal to the second number, and in this problem it's 22. Okay? Our number of runs was 12. 12 is not less than or equal to 10, and it is not greater than or equal to 22. So I'm not going to reject this. So everybody understand how that works? So it's a little bit different from what we're used to. You have a 10 and a 22. If it's smaller than or equal to 10, or bigger than or equal to 22, then you will reject. But 12 is not, it's in between. So, do not reject HO. If we don't reject HO, we're saying it appears to be random. Okay? That is the runs test for randomness. It's a pretty easy test. Just have to calculate the runs and then use your textbook to come up with the critical value. All right? Okay, let's do one more example. Sometimes they will ask you to do a runs test, but they will give you numerical data. If that happens, what you need to do is transform the numerical data to something like this that we can do a runs test on. Okay? And you do that by using the median. So let's do one more example, and then we'll be done. Okay. A researcher wants to determine if the state's lottery winning numbers are random. Test for randomness at alpha equals 0.05 for the most recent winning numbers. Okay. So we have a bunch of lottery numbers, and we want to test if these winning numbers are random. So let's write them down first. So 321, 909, 715, 487, 808, 509, 606, 943, 761. And continue over here. 200, 123. 367, 012, 444, 576, 409, 128, continuing 567, 908, 103, 407, 890, 193, 672, 867, and 003 and 578. Okay, so here's our string of lottery numbers, and they want to test for randomness. Now, here's the problem. With numerical data, you know, each number would be a run because they're all different, right? Does that make sense? So we need to transform this over to symbolic data, and then we can do a test for run, okay? So what you want to do is you need to take this string of numbers and find the median. So your first step is to find the median. Okay? So you could do that by hand physically, or you could put it in Excel, or you could put it in your calculator and just calculate the median. And let's say you did that. I'll cheat a little bit for you. The median comes out to 538. Okay? Just be sure you can do that. You can use technology if this is on a test. All right, now what we're going to do is we're going to go back, and if the number is below the median, you're going to put an A. And if the number is above the median, you're going to put a B. Okay? If the number is the same as the median, just put a 0 or ignore it. All right? So go ahead and go through that. So your string's going to be like A, B, B. Is everybody with me? If the number's below, put an A. If the number's above, put a B. And go ahead and complete your whole string of letters now. So take a minute and get that whole string finished up. Again, if there happens to be a 538 that's the same as the median, just cross through it or put a 0, but it's not going to count, okay? What, is there one that is 538? So, just in your notes, remember, ignore numbers that are equal to the median, if that happens. Okay, double check that you got this. A, B, 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 A, B, A, B, 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 A, 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 B, A, A, B, B, A, A, B, A, B, B, A, B. Yes? Okay. Then just go through exactly like we did last problem. Circle the runs. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 runs on this one? Did you guys get 16 runs?
No.
Great. And count how many A's you have and count how many B's you have. And whichever one's bigger is going to be N1. Okay? So counting the A's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 A's. Did you guys get 14 A's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh man, tied again.
No.
No, this is wrong.
Oh, I messed up. Where did I mess up?
You have an extra B in your
In the
percent.
beginning, yeah.
Fair.
It's
Yeah,
A, B, B, A.
My fourth B is wrong.
No, third one, fourth letter. You have too many B's.
Oh, okay. Oh no, that doesn't change too much though, huh?
No.
So the runs is still 16, yeah?
Yeah.
And the number of B's is
13.
13. Okay. Great. That wasn't too catastrophic. Okay, so let's go to our table. Let's get our critical value. So N1 is going to be 14, and N2 is going to be 13. So we're going to line up N1 as 14, N2 as 13, and you get 9 and 20. So everybody see 9 and 20? Everybody with me on that? So N1 is 14 on this problem, N2 is 13, and if you match those together, you get 9 and 20 for your critical values. Okay? Well, let me put in the HO and H1 real fast. Don't want to skip that. So random, not random. Critical values, 9 and 20. All right, what do? I reject if it's smaller than or equal to 9 or bigger than or equal to 20. Is my runs smaller than or equal to 9 or bigger than or equal to 20? Yes or no? No, it's in between, right? So do not reject. And that means, looks like these state lottery winning numbers are random. Okay? It's a really, really easy test, guys, so you don't want to skip out on this test. Okay, it's really easy. You're just circling runs. Okay? Any questions on this problem? Okay, let's just write out things that we've done, things that are going to be on this last test. just to make sure we're all on the same page. Test number 4. All right, what is section 1 for this test? What is the first thing we did for this test?
That super long thing.
Yeah, super long thing. What is that super long thing called?
ANOVA.
Nope, before ANOVA.
It's a correlation.
Correlation and regression. And guess what? You will definitely have one of these on your test. Definitely. Okay? So there's several steps. You find R. You do a hypothesis. I'll just say a t-test. It's a t-test. Okay? If you reject this t-test, you do regression, right? If reject, which you will, you do regression.
You want scatter plot on that too?
No, you don't have to just get a plot. I think some of the homework problems ask you to, which is fine, but it won't be on the real test. Which is a model. So you do your regression model, and then you make predictions. Okay? I believe the example we did in class is we had a group of people, we looked at their height and weight, then we calculated R, our correlation coefficient, then we did a t-test for R, we rejected HO, which said that height and weight are related. Then I had you guys do a linear model, and then I said, okay, predict the height of somebody who weighs 200 pounds, or predict the weight of somebody who is 7 feet tall, okay, something like that. You will have one of those on your test coming up. That's where we start this, okay? What's the next major section on this test? Yes, goodness of fit, and what is that category called though? It's all underneath chi-square test? All right, so some of us need to study. So we have goodness of fit, and does anybody remember any of the other ones? These two are kind of joined together because they're so similar. Using the matrices or contingency tables. Anybody remember what one of those are called? All right.
Independence.
Tests for independence is the first one. And the other one was homogeneity of proportions. Okay? So, definitely going to have at least one of those on there. Okay, so make sure you can do that. All right, then what's the next major section for this test? ANOVA. Said it every time, right? This is a test for the difference in 3 or more means, okay? And if there is a difference in the means, we find out where that difference is by doing what test? Chefé, yes. Okay, there's also a 2K test, but we didn't do that one. So you just have to do the Chefé test, okay? The 2K test is a little bit limited because all the samples have to be the same size, and that doesn't happen all the time. Okay, and then the last major section is this chapter that we've been working on with the non-parametric statistics. Okay, let's see if we can remember all of these non-parametric stats. So, let's see if we can do this. We did the sign test first. Yes. We did the paired sample sign test next. Okay. What was after paired samples? Anybody remember? Wilcoxon rank sum test. Now, once you start seeing this word rank appear, you need to be able to rank data. Okay, and that's something we spent a lot of lecture on. Make sure you can do that. Then what was next? Sign rank, Wilcoxon. Again, you see rank. What was after Wilcoxon signed rank? Yeah, the H test or the Kruskal-Wallis. also called the H test, and that one obviously does ranking as well, was after Kruskal-Wallis.
What are we learning today?
That's what we just did.
Okay, I'm
Runs
not missing
test for
anything, am I?
Mm-mm.
Make sure I'm not missing anything here. So
Runs test
we
for-
did, yeah. So 7 is runs test for randomness. And 6 is randomness. The RS, the Spearman rank correlation coefficient. Spearman rank, and again, rank correlation. Okay? Now, on this test coming up, if I asked you to do any of these 7, I will say do the Spearman rank correlation, or do the Kruskal-Wallis, or do the runs test. Okay, I will state which test to do. On the first couple of ones, I won't. Okay, just on the non-parametric ones, I will tell you do the sign test or do blah blah blah. Okay? Questions on that? Yes.
For the Wilcoxon sign rank test, are we gonna do the summarizing results where they have that Z equation?
The summarizing results with the Z equation. If it's not something I did, then no.
Okay.
Okay. I'll just have you do the test the way I did it in class. Okay. Other questions? Okay.